Elon Musk and NASA just shocked the entire space industry with SpaceX's insane new engines. When it comes to space, there's a problem with our human drive to go all the places and see all the things. A big problem. It's, well, space. It's way too big. Even traveling at the maximum speed the universe allows, it would take us years to reach our nearest neighboring star. But another human drive is finding solutions to big problems. And that's what a NASA engineer has been doing in his spare time. He's produced an engine concept that he says could theoretically accelerate to 99% of the speed of light, all without using propellant. Today we're going to talk about the amazing new light-speed engines that SpaceX and NASA have collaborated to create. How will these engines be developed? If it's going to work without propellant, then what'll be its fuel? And most importantly, will a human be able to travel in a vehicle with such an engine as its thruster? Well, stick around till the end as we answer these questions and more as we delve deeper into these new engines that'll revolutionize the space industry forever. So let's begin the video. First, let's look at the current status quo. All of SpaceX's rockets use the Raptor 1 engine or the Merlin's 1D engine. Raptor 1s use methane and liquid oxygen fuels, making it one of the cleanest burning rockets available. And thanks to these high-thrust engines, precise throttle and gimbal ability, SpaceX has pioneered self-landing rockets. While Raptor 1 has been refined over the years, it's now an old design. Its construction is complex, difficult to manufacture, and has a long turnaround between launches. It also has hit a thrust ceiling of 185 tons, meaning it'll struggle to reach Musk's demands for a Mars-bound Starship. This is where the new engines come into play. NASA engineer David Burns has uploaded a radical idea to NASA's technical report server under the title Helical Engine. And it works on paper by taking advantage of how mass may change at relative speeds, those near to the speed of light in a vacuum. It has not yet been reviewed by a professional. Understandably, this article has sparked interest comparable to that witnessed in the early days of the EM drive. Yes, there have been some theories suggesting that the engine may break the rules of physics. For a bit of context, it's important to know that the aforementioned EM drive was NASA's first foray into the idea of actually trying to build an engine capable of faster-than-light travel. So what exactly is EM drive all about? First introduced in 2001 by Roger Scheuer, a British chartered electrical engineer with 48 years of experience in the space and defense industries, EM drive is a radio frequency resonant cavity thruster idea with possible uses as a spaceship thruster. It is claimed to create thrust by internally reflecting microwaves, in violation of the law of conservation of momentum and other physical principles. The media has frequently referred to the gadget as the impossible drive. Explanations for how the EM drive can function go well beyond the known limits of physics. Perhaps it's interacting with space quantum time's vacuum energy, despite the fact that space quantum time's vacuum energy doesn't enable anything to push off of it. Perhaps our notion of momentum has been shattered. Perhaps it's brand new physics, as announced by the EM drive tests. There's no official design for this device, and neither of the persons who have claimed to have developed it has committed to explaining how it may function as a thruster or what elements constitute it, making it impossible to determine whether a particular object is an example of such a device. NASA's Advanced Propulsion Physics Laboratory reported observing a small apparent thrust from one such test in 2016, a result that has not since been replicated. Subsequent studies have indicated that the thrust observed was a measurement error caused by interactions with the Earth's magnetic field or thermal gradients. In March of 2021, scientists from the Technical University of Dresden published 3 papers explaining that it was a total fluke. The thrust was explained by outside forces. So are you guys enjoying today's video? How exactly would such an engine work? And is it feasible to produce it in real life with the resources we have? We have the answer, but do you? So while you think, do subscribe to our channel and click on the bell icon to receive instant notification about all our future videos. As for the helical engine, while it is intriguing, it's unlikely to defy the laws of physics anytime soon, despite the claims. Although it has been met with skepticism from some quarters, Burns believes this concept is worth pursuing. Well, Burns depicts a box with a weight inside, strung on a line, and spring at the other end, bouncing the weight back and forth as a thought experiment to demonstrate his notion. In a vacuum, such as space, this would jiggle the entire box, with the weight appearing to remain motionless, much like a GIF stabilized around a weight. Overall, the box would continue to wiggle in the same location. However, if the weight's mass increased in only one direction, it would create a stronger push in that direction, hence thrust. We think this should not be entirely feasible, according to the concept of momentum conservation, which states that the momentum of a system remains constant in the absence of any external influences. Einstein's theory of special relativity says that objects gain mass as they're driven towards the speed of light, an effect that must be accounted for in particle accelerators. In fact, a simplistic implementation of Burns's concept would be to replace the ring with a circular particle accelerator, in which ions are swiftly accelerated to relativistic speed during one stroke and decelerated during the other. But Burns thinks it would make more sense to ditch the box and rod and employ the particle accelerator for the lateral as well as the circular movement, in which case the accelerator would need to be shaped like a helix. However, there is a particular relativity flaw. Objects gain mass when they approach the speed of light, according to special relativity. So if the weight is replaced with ions and the box with a loop, the ions can potentially move quicker at one end of the loop and slower at the other. Burns's drive, on the other hand, isn't a single closed loop. It's helical, like a stretched out spring, which is why it's called a helical engine. The engines accelerate ions confined in a loop to moderate relativistic speeds and then varies their velocity to make slight changes to their mass. The engine then moves ions back and forth along the direction of travel to produce thrust. The engine has no moving parts other than ions traveling in a vacuum line, trapped inside electric and magnetic fields. The helical chamber would have to be rather huge, according to the scientist. To be accurate, it's 200 meters, which are approximately 656 feet long, and 12 meters, which is approximately 40 feet in diameter. It would also require 165 megawatts of energy to produce 1 newton of thrust. That's the force necessary to accelerate a kilogram of mass per second squared, which is comparable to a power plant. Proposals for propulsion-free vehicles like helical aren't exactly new, though. Robert Cook, a U.S. inventor, patented an engine in the late 1970s that allegedly turned centrifugal energy into linear motion. Then in the early 2000s, British inventor Roger Scheuer suggested the previously mentioned EM drive, claiming that trapped microwaves might be converted into thrust. No idea has been proven conclusively, and both are widely believed to be impossible due to a violation of a fundamental physical rule, the conservation